Now we're actually approaching the moment we've all been waiting for, which is, we've been talking about, do we build infrastructure or do we think about use cases? And really, I think what Shaw brought up is that you really do both. Like, we do need to talk about what are we doing here, but then if we had to wait for that, with every technology, then we wouldn't have the internet. We wouldn't have many key things, is that we have to start actually building infrastructure, especially if we want to anticipate how to prevent these kind of walled gardens from happening. Okay. Yeah, Ramesh is asking if you can all move, sit down, take a seat, because you're going to enter a 1 hour quick, it's like, think of it as like 10 short mini documentaries on what could the future of this infrastructure look like. We're not going to talk about use cases. What we were talking, the whole point of this first session is we're here to spotlight some of these solutions that have been coming. I forgot who said it, but one of the recommendations, someone said, we need to cast a wide net, right? And that is what we're doing with the proposals. We're casting a wide net, and we're still open to more proposals. So after hearing this, if you're out there in the world listening or in the audience, if you're like, look, I have something that needs to be part of building out this interoperability index. Now your time is, speak up, come talk to us afterwards. And as you've heard from many of our members of the Advanced AI Society and also speakers in our community, they're saying, most of them are saying we should not slow down, even though we don't know exactly what it is, because we already can anticipate that confidentiality, especially as what Lisa and Dylan was saying, is such an important part. We have to consider these things now because they take time to build. So with that, we're going to enter in like a mini documentary session. We're going to do like 5 minutes back to back. And each speaker is going to come up and you're going to hear from them. And some of them have already presented once, but what I want you to do for those who are speakers and those who are if you've already spoken, if you're participating in the workshop, make a note of these presentations of like, when you go into the workshop, we want you to tell us, hey, I disagree with this, or I really agree with this, or I would tweak this, or we have something to add to it. So keep a running log. And when we go through the workshop with the interoperability design brief, we're going to ask you to make notes and give us your feedback. And if you're in the audience and you're like, look, I was not invited to this workshop and I have to be there because I actually have something to work on, contribute with the Web3 quilt, come talk to us afterwards. We're here. We do not want to, have you left out. But you're going to have to work during this lunch. So with that, I'm going to bring up our first protocol, our first proposal, which is Beacon Protocol, Phil McManus.
Thanks, Jespersen.
You have 5 minutes on the clock. I'm going to say, look at Angela. Where's Angela? You're going to get, every speaker is going to get a 5, 4, 3, 2, 1 countdown. And then we're going to go because people need to eat.
All right, excellent. Well, thank you so much, everyone. I'm Phil McManus, CEO and co-founder of Beacon Protocol. We're focused on, we think we can bring to the Web3 quilt is building out a private data layer. One of the things that we've heard a lot of conversation about today is some of the challenges around data. Where is it stored? How's it accessed? How do you know where it came from? One of the things that will continue to remain a challenge, we've all talked about, is there's a lot of private and proprietary data that will be used by agents, whether that's your personal information or proprietary information that a business has developed that remains locked away in these silos. And data discovery will continue to be an even larger challenge. We've already seen a lot of things when we talk about how AI uses data around thinking about price discoverability, right? What's the value of that? This whole world of data being collected, things happen, and then someone profits really needs to change as we look at how agents and models will start consuming data at unprecedented rates. The way that we built things out with Beacon Protocol is really interesting, and we've done it in a way that is storage and compute agnostic data collaboration. So what we have the ability to do is allow data to be encrypted at its source. Provenance can go on-chain around where that data came from, as well as access controls. We also structure that data in a way that the data can be discoverable via the metadata. I think metadata is going to be an incredibly important part of anything around agent registries and how data is being accessed. But also, we need to know where it came from so that that data creators can retain control of not just their privacy, but also monetization. And I think one of the other big things that we've really seen that's missing in a Web 2 world is there is really no concept of a read ledger, because once you have access to data, you can continue to consume it. Copy paste is very, very common. So how we see this, working, and I think an interesting thing to think about is not just around keeping private data and private compute, but also data minimization. So think about agents collaborating on a process where, let's talk about an agent booking a vacation for you. There's a lot of information that goes into that. They're going to go ahead and task in something like a flight booking agent, a hotel booking agent, and even a restaurant booking agent. All of those agents will need a lot of interesting things. They'll need both your personal information. So I consider it sort of a full and a limited set. Think about your passport, right? Will also need to be part of that. Your food preferences and that itinerary. This is all going to be happening in memory as agents collaborate across that. Well, does the hotel agent need your passport? Does the restaurant agent need your passport? Certainly not. However, to book that flight, you're going to need the passport information to put that in there. So there's a lot of interesting things that happen if you can control access to data and minimize it in a way that agents can do it without having humans directly in the loop. That's why we structure it in a way that raw data can go into our protocol. There's a few different things that happen. The first thing is when the data is encrypted, access controls, the encryption schema, and the access lever can go on any chain. So as we talked about, there's this question of should this all be centralized somewhere, or is it important for it to be able to be accessed across multiple chains? We see access to data being critical, that it has to be decentralized and available across multiple chains. So EVM and SVM compatible support around being able to decrypt that data, the ability to have metadata and indexing on the information about what's contained in the data without revealing the underlying data is an important part of a registry. And what becomes really interesting as well as we think about storage, we believe that there needs to be a world where data can be stored anywhere, yet have that provenance across multiple chains and distribution. And the way that that works is data can be encrypted in multiple parts, so you can separate those pieces of information in that process, like your passport, like your food preferences, like the itinerary that's being developed on that vacation that agents are collaborating with. And because it's done in a way that it's storage agnostic, this can actually lend itself to the challenges that we see around AI agents collaborating in memory and being able to also think about closing down the state of a memory and then bringing that process back up and that agentic collaboration process. Ultimately, we've designed this in a way that has a couple interesting things. One, we focused on primarily being an SDK for interoperability across Web 2 and Web 3, because as much as a lot of us are very deep and native into Web 3 in the room, there's still a lot of things happening in Web 2, and we need to be able to bridge both of those. We also think it's important to abstract some of the UX complications like wallets, so being able to execute meta transactions is a great way to be able to do that, and also being able to have ways that agents can be able to execute this type of data transaction, being able to put those controls in place, but still allowing humans to remain in the loop by ensuring that any way that data is being given consent around how it can be used, things around thresholds of scores of agents. So for instance, I don't want an agent with a reputation score less than 100 touching my passport, but if you want to know my food preferences, all right, sure, I'll lower that down. Those are the types of things that need to be respected as our preferences as agents use those data without humans needing to constantly be in the loop. So thank you very much, Phil McManus from Beacon Protocol. Feel free to follow us on X, drop me an email, and there is a B in Beacon Protocol on that website. So thank you, everyone.
Hello, hello, hello. Hi, everyone. I am Michael Kantor, and I am the president of Hashgraph Online. It's a pleasure to be here today. Today, I'll be telling you guys about OpenConvey, registry brokers, but you're probably wondering, what's Hashgraph Online? Well, we develop open source standards, and we have over 20 million transactions in mainnet today. We also create tools and services for fully on-chain and decentralized agentic internet. Hashgraph Online and its standards, including OpenConvey, are governed by 10 organizations like Hashpack and Bonzo Finance. Our code runs on Hedera, a trusted DLT network that's backed by up to 39 leading organizations like Google and IBM. So what's OpenConvey? Well, before we get into that, we have this shared vision with NANDA, with isolated registries that weave into a single fabric. And in that shared vision, we see it as being a world where things are discoverable, agnostic, and immutable. You have these registry brokers which act as DNS for AI agents. you'd have multiple brokers, which prevent centralization. There's actually a 2 of 3 consensus model that makes this really interesting, but we'll talk about that soon. Ideally, these registry brokers connect Web 2 and Web 3 agents, so you can get the full scheme of agents ever across the internet. You'd have federated discovery, which means anyone can federate their registries. Some of this was talked about earlier. You might have really specific niche registries that really need governance, right? And they can federate, and they can join the registry and become indexed, where you have Web 3 ecosystems like Solana, Ethereum, et cetera. They can all join this federation. And all of this data, it's stored 100% on-chain, where you have trust attestation. So the current state can be replayed and put on-chain as HCS1 files, so we can always see how did we get there, because that matters, that's important. And those relationships are stored forever on-chain. So today, here's a little bit of a demo, if this works, where we have a registry broker. You can see in there, there's multiple registries being populated today, like virtuals protocols, OpenConvey, and others, like even NANDA as well, an open router agent so you can connect to and start talking to. You can say, what's the capital of New York? It'll tell you it's Albany. You're talking on-chain through A to A in this example. So, sorry, what does the architecture look like? A registry broker, it starts with external registries. We have all of these external registries all over the internet. OpenAI, NANDA, Enterprise, HTTP, very federated, governed registries, Ethereum smart contracts, near programs that all kind of link together. And with these external registries, you have adapters. So adapters are built, and they run inside of a registry broker to pull this data, normalize it, virtualize it, put it into a state that anybody can understand. Then you have the registry broker itself. Registry broker has a 2 of 3 consensus. So the idea isn't that there is a centralized service. It's actually a node. And you'd have multiple independent, geographically independent entities come together to run a registry broker. So as a registry broker, we go and we index and pull all of this data together. We say, OK, the state makes sense. Then we vote on it in real time. We agree. And then we put it on chain as a trust attestation. And the end result is that you can contact any agent on the planet. We have agreement that the data is valid, and we get discovery, interoperability, and trust as an end result through these registry brokers. So we're doing a lot of research, and we'll be publishing a research paper soon on this as well. But through that research, we had some questions. One, agent cards are really great and very important for something like a registry broker. How do we get the entire internet to start using agent cards? To Shaw's point, how do we incentivize this? And how do we start running agents all across the internet and get to this trillions of agents point? Identity. Identity is really important. But what does it mean? And what should be included in a virtual ID in something like a registry broker system? Is it your DID, your Web3 domain? Is it your public key? And signatures. I think signatures could be even more important than identity itself, because every agent will have a signature. It might be the key that they use to sign. It might be their IP address, their SSL certificate. What should be included inside of a signature so that I know your agent is legitimate and it hasn't been an imposter of some other agent that's doing the same thing? And last, trust, especially when we're talking about money Legos like we do in Web3 so often. How do we trust that these agents are legitimate when it comes to executing financial transactions? Or do we lean into more trustlessness through smart contracts and programs? Thank you.
All right, Christian, take it away with Acurast. As you can already see, there's no agreed upon solutions. It's a wide variety.
3 minutes.
Yes. 5
All right.
5 minutes.
Thanks. All right, don't worry about it. Although my name is Dr. Killer, gladly I didn't go into medicine, so everything's fine. Just doing some computer science here. All right, confidential and distributed agent indexing with Acurast and the NANDA registry Quilt. So as you can already read from that, our expertise goes into confidentiality and also distributing things that are in contact with the registry Quilt, because everything is interconnected and not hierarchically organized. So as you can see here, Acurast can actually empower this interweb of connections where we can have different entities such as NL web agents, decentralized agents, whether they exist or are used today That's another discussion. IoT agents definitely exist and are used, enterprise agents as well. So Acurast can sort of interconnect all these things by providing compute, routing, and storage. Because we have a decentralized network of around 100,000 devices globally, fully distributed, decentralized. Why do we use phones? So that's usually the first thing people ask. I realized over the course of the last 3 years, it starts to diminish a bit because people start to realize that the phones are actually really powerful and secure. They're also decentralized by design because there are, I think, last year it was 1 billion less phones than humans on Earth. So I guess next year, since we sell around 1 billion of phones per year, that should be more phones than people on planet Earth, which is kind of crazy. And also through the average lifetime of a replacement cycle of 2.75 years, that means that we certainly will have more phones than people right now. So also they are verifiable by design, meaning that I'm going to refer to our colleagues of Secret Network and Bala as well. They use trusted execution environments as well. We use them too, but we go on a hardware level, meaning that depending on the device, we actually bootstrap a trusted execution environment. For example, if it's a Google phone Titan coprocessor, we really do that on an Android level. And then that makes it really secure, just as if you would leave your phone locked somewhere. You also trust that nobody can extract information, right? Whether or not that's possible, that's another discussion for a beer or a coffee later, because that goes into the tin hat foil section, and we're not going there right now. So, and that also means it's confidential by design, because we have that trusted execution environment, and of course we have lots of other protocols in place to achieve security. Now, taking a direct reference to the NANDA Quilt is, for example, if a user would have a query that would go through the Acurast processor, and also with all the metadata or agent facts, we can actually do adaptive routings, which then select the optimal node based on latency, throughput, or whatever kind of metrics you choose, right? And that, of course, is returned to the user. On the bottom, you can see a verification process with verifiable credentials, for example, where an agent provides these. Then they pass through some sort of consortium or the consensus mechanism. We use DPoS, so we use delegated proof of stake. So who was it before? Let's catch up later and discuss whether or not that makes sense. I think economically incentivizing security in an adversarial network is a way to achieve security, right? I think this has been proven many times over again, and I don't know any other way on how to do that right now. Also, Nakamoto consensus is the best way to achieve that, but that's another discussion as well. So as you can see here, trust verification can also be covered. And then here, I'm going to cut this very short because this is also something that we, as engineers first, thought about, of course, that we can develop standardized protocol adapters, have a pilot program, and then also optimize for performance as well. And then when everything is in the real world, we need to think about compliance as well as governance as well. So thank you so much for having us.
Hi, everyone. My name is Sharath Chandra. I'm here from Napa, California. I'm an independent researcher and the architect of Lyra Tech. Some exciting stuff. So we're going to talk about space. Where we are, thousands of satellites in the orbit right now, projected to go up to somewhere between 30 to 50,000 satellites over the next 5 to 6 years, probably more. A lot of it is manual coordination, multiple jurisdictions, FCC, FAA, ITU, ITAR, NOAA, ESA, many different space agencies around the world. Not enough experts trying to coordinate all of the processes and the compliance process that needs to go in before you can launch something into space. And I believe this is a disaster waiting to happen, both in the process of it and in space. Inspired by NANDA's Internet of Agents vision, I started the process of creating, working or prototyping agents to mimic registries and a minimal registry, to test the Quilt concepts. The goal of this prototype is to test agent identity, capability declarations, propagation across multiple authorities. In this case, particularly, I've used FCC, FAA, and ITU for frequency coordination. This is an early stage system, so I'm still learning and building. The challenge was how do we build an interoperable quilt of AI agent registries. So what I focused on particularly were 4 agents running currently. The basic core infrastructure behind it, the agents operate with multiple status, peer messaging, and internal rule maps. What this enables for, at least in the near future, from where I see, is the peer discovery across registries, the trust network across the gatekeepers here, in this case, the multiple jurisdictions, the collective intelligence, and in what I'm hoping that it'll do for the space industry is that the ability to make split-second decisions, resource sharing across competitors, which there's plenty right now, consensus across jurisdiction in real time, and hopefully a sustainable operation for generations on both Earth and in space. My long-term hypothesis that satellites and missions could be modeled as autonomous DID agents with embeddable, verifiable jurisdiction and compliance state. Again, just a hypothesis, and it's a vision that I have, and this is sort of the guiding direction for me to prototype this and to model this. So I do have a live test bed and the registry right now to test with the NANDA team, and I don't have all the answers either, so I'm hoping that I'll be able to figure a lot of those out over the next couple of days. So thank you.
All right, hi everyone. I'm Michael from the ArtiNet project. And I want to talk to you about building agentic networks. And to start with, I'm going to kind of give a brief introduction to the ArtiNet project, kind of what we're working on. And then from there, I'll kind of dive into our proposal for NANDA and how that kind of fits the larger vision of being able to create these decentralized agent networks that we're so interested in. So to start with, as a lot of us know, agents are becoming more and more powerful each day with the new tooling, new orchestration, new communication protocols. But for people who want to get involved in it, it's an uphill battle in terms of being able to actually set a lot of that up. We have these agents kind of being able to reach out and touch the physical and digital world. And it's great, but for people who have the technical expertise, even that for them, it's a bit of an uphill battle to actually be able to build everything up. So what we've actually provided at the ArtiNet project is a platform for people to be able to create, test, and deploy all in one place and not have to worry about the communication logic that's underlying all of it. We've already built that into the platform. And really what this is empowering people to do is it's allowing them to kind of focus on what they actually want to build and not necessarily how they want to build it. And we think this is pretty interesting. And we actually have a new feature that we just released as well that we're calling the grid, which is essentially taking agents that people are already deploying on the ArtiNet platform, being able to take those, put them into what we're calling the grid, and essentially be able to create these orchestration workflows. So they're able to take these agents, whether it's a conversational agent that they've created for something, or whether it's a MCP tooling agent that allows them to be able to search the web. They're able to take these, put them into the grid, create this orchestration, and essentially we handle all the communication for them in the back end. All they have to focus on is really what they're trying to create. And it's a really straightforward solution and allows them to really do all the testing right there. And we think this is going to be pretty empowering for a lot of the people as they try to make AI have more of an impact and use more of that tooling, use more of that communication protocols and the orchestrations underlying all of it. So getting into kind of our proposal for NANDA, as we've talked about, there's a lot of challenges that come with creating decentralized agent networks. Discoverability has been brought up. Interoperability has also been brought up. We have all these agents in different areas, and we need them to be able to discover each other, and we need them to be able to actually communicate and work together. And we have a lot of new players coming into the scene that is kind of creating these fragmented ecosystems, and we're really trying to avoid these walled gardens that we've talked about during the summit already. So the proposal that we actually had was for a deterministic agent identifier, or we're calling it DAID. Really what this is, it's taking that agent card information, the capabilities of the agent, the descriptions, hashing that together with also the author's identifier, and creating a DAID. And really the powerful thing about this is that other registries can really create the same DAID. It's deterministic. It's pretty low cost and efficient for people to actually be able to create these hashes. And what we're really hoping is, because it's building in all this information for the agent card and the registrant ID, you're avoiding the duplication issue with having multiple agents being able to be created in this exact same agent. That's built into this identifier, so you can avoid that. Additionally, because we're including the author's identification, you're also avoiding the piece of authors being able to actually deny their ownership of their agents, which helps with security down the road. And really another key piece of this is with people adopting this, it would essentially lead us to kind of separating out the identifier piece from the authentication piece. So registries can endorse the agents that they want and do what they want on that front, and then essentially have this kind of identifier in place. That's all I have. So if anyone wants to chat about DAIDs or the ArtiNet project, feel free to reach out.
All right, so I'm Matt Dionis, a software engineer at Radius, where I focus on agentic AI. And before I dive in here, I just want to talk a bit about my background, because somehow what I've done over the last decade has kind of all come together in what we're building and is related to this quote. So I spent about half the last decade at Circle leading the internal tools team, learning a ton about legal and compliance and regulatory issues around crypto rails. I spent about 2.5 years after that at Auth0 doing OAuth work and trying to make OAuth both secure and user-friendly, which the user-friendly, developer-friendly can often be kind of tough. I briefly hopped into the NFT ecosystem and built some token gating solutions there. Then I got a chance to spend about 18 months with Sean Neville, back with the Circle folks at Catena Labs, building generative AI. And in January, I joined Radius. And the main reason I joined Radius is because of their super high throughput, low latency, super low transaction fees. I feel like these are table stakes for what we're trying to build, both with NANDA and outside of NANDA, just for this AI agent economy. So warning, I'm gonna double down on economic incentives to both bootstrap and secure these networks. And let me define EVM auth really quick. So I can't take credit for this. My colleague at Radius, Sean Scoville, built this out. It stands for EVM, Ethereum Virtual Machine Auth, both Auth-N and Auth-C. Think about I'm sure you've all heard of X402, H402, all these 402 protocols. EVM Auth is like that plus a little. So what I want to talk about here, and this is a grand vision for where we could get, is this EVM Auth flywheel, self-reinforcing growth. I see two major problems in fully autonomous generative AI that could be deployed to production systems right now. One is context engineering. Prompt engineering was a hot term for a year or two. Now folks are talking about context engineering. The fact of the matter is you could have GPT-5, which feels close to AGI, without accurate, proprietary, up-to-date, even real-time data being fed in. Like, it's a garbage in, garbage out problem. And I'm sure a lot of you have found web search can kind of get the job done maybe half the time, but I don't think you'd want to ship to production like a financial AI agent that is managing your money based on Google web searches. So this, again, I talked earlier about how we need to have good developer experience. And I am super focused on MCP servers. Instead of trying to build this quilt and be everything for everyone, I personally think we should focus on where are the builders right now. And the model context protocol is really where they are. This is actually an SDK we're going to release open source this week from Radius. And this is how easy it's going to make MCP server monetization. So actually, I sold us a little short here. If we default this chain ID and this RPC URL to our Radius testnet, all you actually need is a contract address. You basically deploy an auth smart contract on Radius, and what you get is this EVM auth.protect method down here. That's the only line you need to write, and that number 1 simply represents a token, an ERC 1155 token in the Web3 world. And what this allows any MCP server builder to do is to begin monetizing their content, their tools, their prompts, their resources in as little as 1 line of code. I'm not trying to give anybody a headache. This is a high-level architectural view. We're going to release this later this week to the EVM auth MCP server, but what this is covering is basically all of the cruft that we abstract away in order to get to this level. And the idea is that starting this week, Claude Web, Claude Code, Windsurf, Cursor, anything that supports MCP server OAuth, you can immediately plug into this system and basically access data through micropayments. And I think this is important for the Quilt because micropayments is just the beginning. This isn't a proof of payment system. This is a proof of token ownership system. So you could think going through DID, digital identity flows, going through compliance checks, any due diligence check you can think. If your agents can go through that and securely be granted a token that sits in their wallet, that could unlock access to premium and more secure and sensitive resources. So yeah, that's really where I'm at. And for anybody that wants to talk about this more, Quilt is the right term because every project that's come up so far, I've been thinking about how we could actually integrate with them. So it would be nice to collaborate. Find me later if you want to chat further about this. Thank you.
Braxton for Project Liberty. And we heard your note on the quilt as naming is always an issue. So I'm sure Ramesh heard that loud and clear, that quilt is a love language.
Oh, yeah.
Terminology.
Thanks. Thanks, Trisha. Yeah, we're actually, our main goal here is actually to join the quilting party. We used that term, a few years ago, but that's a good sign when people use the same terminology. And today I'm less focused on driving adoption and more focused on finding collaborators. So I'd love to, if you see an intersection with what we're doing, I would love to talk to you. A few areas I've already kind of been taking notes here as I've watched these presentations. But I think it's all about where do we sequence. The problems are so vast. I think the sequencing of where we interface and how we work together is going to be the biggest challenge over the next few months. So hopefully we can get those dialogues going really, really quickly. You all know the problem here. We've been looking at this for, in our team anyway, for about 15 years when we first started processing the full Twitter fire hose back probably, that was actually 2008 or 2009. And we kind of watched as, building on the layers of decentralized network protocols for TCP IP and then the web, we saw people were constructing these graphs, but yet private companies own the graph, own the networks, and that was incredibly problematic even back then. And obviously we watched now over a decade as those network effects led to consolidation of power, et cetera. So we definitely have a concern that's been rising, and we think that now with agentic AI, the disruption we're seeing is both, somebody has earlier said, very concerning and very exciting at the same time. We think it's the first opportunity to really break through these models that we've seen in a long time, to actually kind of insert some new infrastructure. At the same time, if nothing happens in favor of humans at this point, we see an acceleration of power consolidation that's going to basically be a lot worse than what we've seen to date. So we think there needs to be some sort of kind of human context protocol. And just like the quilting terminology, I just found today, some of my staff sent me that some folks have written a paper on human context protocol, 2 of which are in our alliance at Project Liberty. So clearly this is in the air and in the water. And so we're just looking for other collaborators here to work on the kind of human interface. So when I started thinking about projecting how these agents will work, it's pretty obvious that the agent-to-agent communication will be orders of magnitude higher frequency than agent-to-human communication. That said, the human-to-agent communication will be the very critical part. I think a lot of people will be like your own chairman of your own board. You won't have time to make microsecond level decisions, millions of decisions in short periods of time. Your agents will do that. You'll need to basically to have control over what they're generally doing and some kind of general governance over the agents that interface with you, which will be a tiny fraction of the agents working. So that's what we're focused on. A lot of protocols focus on key elements of this, just how do agents communicate with each other, A2A or MCP for data, but there needs to be something that's really focused on the human element and the human control. So we focus on a few aspects of this. And the first is we firmly believe, after looking at this for over a decade, that there needs to be a shared state layer. Some of that can be federated, some of that can be peer-to-peer, but we do think there needs to be some common shared state. Raise your hand here if you use Google or Apple to log in. Do you guys use, anybody not use a login like that? I mean, it's a pretty small group. I know Dave doesn't, yeah. So, the problem we have here is most people, their digital existence starts with a kind of corporate kind of representation of you, and you only have access to a small fraction of the data they have, and you only have rights over limited aspects of the data. So we believe there should be a shared state layer that starts with you, and then you can delegate and revoke access to your data, and that's where it kind of opens up a few key areas of axes of kind of control points. So there's 4 areas we focus on with this. We focus on identity, we focus on the social layer because that's where the powerful network effects exist. We focus on the software that's employed, and that's the portable context. And then the 4th piece is the economics. So that's kind of the key areas of focus of our work. Obviously, that's a massive surface area, so we're trying to sequence all this work. And so that's why I'm hoping today we can just start to identify some places to explore work with all of you. I should mention we already have a fairly large kind of installed base for a Web3 project. We have a few million people on chain. We just pulled all of Blue Sky onto frequency recently as well. That's another 8.5 million active people going to mainnet this week. And so we already have a base that's large for Web3, but it's de minimis when you think about the entire internet and obviously social networking, et cetera. So we're hoping to find places to collaborate. We obviously see a direct connect to what NANDA is doing in a number of ways. It's listed here. You can read those yourself. But if you see what we're doing and think it's interesting, please look us up. G2's here. I'm here. We'd love to talk to you and see if there's ways to collaborate. We'll leave it there. I think I'm out of time. This is my AI version of a quilting party, by the way, with bots. So I was like, yeah.
Look how loved the quilt term is, Ramesh. You really hit it. You're in. All right, next we have My Life.
Thank you very much. Hi, I'm Erik Jespersen, co-founder and platform architect of My Life. Is there a page down, or do I? Next button can do it. Yeah, sure, thank you. I'm going to go softer on the tech today. I want to accentuate the human side of things as we're road mapping these NANDA innovations together. From outer space, where Sharath brought us, we're intrepidly going to investigate. You want me to put that there? Oh, yeah, thanks. Yeah, I'm old, I need to read my notes. So they say, that's very kind of you. Today, we're going to begin, we're going to move to inner space. My Life is a 501c3 nonprofit with a human-centric platform for personal digital legacy building to save your intelligent time capsule for posterity. And today we begin our journey as a case study for moving from Web 2 to Web 3. This outcome will be more than just an upgrade. It's a deepening commitment to our ethics, principles, and values, and our vision of a cohesive ecosystem freely available for universal human empowerment. NANDA. If nothing else, and it's so much else, My Life is about preserving human stories safely and truthfully in ways that matter to the people who told them and to the people who come after. And from day one, we've helped members capture, shape, and share memories and explore who they are. And we realized you can't ultimately build ethical legacy systems on centralized platforms. You can't manage human memory with Web 2 scaffolding and call it secure. And you can't promise someone their story will last unless you encode that promise. So we're turning, as we expected from the outset, to Web 3 foundations, as what we're really building is a promise to ourselves and to posterity. I remember the moment the realization hit me on a cushioned chaise overlooking the garden. Something about dandelions. They were about to hatch and carry their DNA across the field in time to preserve the beauty and the integrity of the original. What if, like seedlings landing in fertile ground, all the ideas we shared, the feedback we gave, the intentions we express had continuing values to others? And what if the intelligence representing and copy protecting you, your ideas and your narratives, your assistive intelligence avatar could filter, route, and consent to sharing, and even compensation, your insight with the right parties, be they family members, generations to come, medical researchers, cultural institutions, or even for-profits? Now, my life right now lives in the applications, communications, agent, and data layers of the Quilt. We're a headless platform, and we expect a lot of innovation actually in the application for layer as we're going forward. So we're going to soften our resources there. But what we need to do for this project is we aim to build out our security, protections, and authenticity through implementation of Web3 in our data and comms layers, while particularly looking to partner with like-missioned NANDA entities, like many of you, who are emerging in the trust, especially in the trust, transactional, and decentralized compute spaces, and I've heard a lot about that, so I'm very excited. My life exists already in the Quilt's Web 2 perimeter via MCP and A to A right now, but the journey to Web 3 is how we bring the rest of our cohesive vision in. We'll host and create NANDA registries, we'll upgrade our storage to decentralized vaults, we'll issue verifiable credentials to memory agents, we'll implement natural language-driven smart contracts, and eventually help form a first-hand legacy-centered DAO. So what's my life's value to the Quilt? Well, we'll share what we find out, at the very least, as an open source technology and lessons that we learn from this journey as we migrate, adopting NANDA Web3 prototypes and partner assistance. We're already in the base registry. We're building registries for memory agents with NANDA's server technology. We're also seeking out aligned individuals in the W3 identity, smart contracting, decentralization, and governance space, and especially those who want to build an affinity-first, human-forward solution. So thank you all for helping ensure that the future of intelligence is a future with memory, story, presence, and meaning, and humanity by design. Thank you. I didn't do it. I don't know.
Andy Singleton from VibeStation, presenting some ideas from our AI scan release. I heard a lot of people complaining that AI doesn't work very well, and I totally sympathize with that. But imagine if you're from the Web3 world, or even worse, from the DeFi world. So there's about 1 billion people who love and use AI, and probably only about 2 million that use Web3. So that's where all the new users are. There's probably 10 or 100 million coming in with stable coins, people who are going to get stablecoin payments. So that's really the overlap, that agents and AI will probably use stablecoins for payments. But in order to bring this sort of weird blockchain world to actual humans, we have to go through these AI user interfaces. And so that's what we're going to do here. We're going to make a unified user interface that can use any part of Web3. And you can see that over there, how we might do that on the right side diagram. We could build a block explorer for AI. So humans use block explorers to interact directly with smart contracts. We can describe our smart contracts to this type of block explorer, AI scan. The problem is that we're going to end up with actually thousands of smart contracts. And this is a generic problem in AI, that we are gaining power in AI by giving AI thousands. I saw somebody who dumped a pack of 10,000 tools this morning. So we're giving them tools to sort of use everything in the computing world. But if you actually ask the AI to do that, you'll find that it gets confused at about 10 tools. So that's a problem for everybody here in this room. And there's a couple ways to solve this problem. One way is, you see the vibe-coded UI there, over there on the right. That's what happens when you give the boss one of these vibe coding tools. I used to be a good programmer. Fortunately, you can effectively use this tool to describe your smart contracts in your protocol and create a bundle of tools and prompts. And that is the same thing that we do with agents. So it's essentially an app model of the world that we're going to we're going to create these apps that are AI experiences instead of web experiences. You can link over to the Vibe client, the AI client, which will pick up that bundle, and then you can do something useful. Over time, it'll switch and get you to the right bundle for the right task. So that's one way of looking at a quilt of agents. It's a bunch of bundles that humans make. And that's sort of the first step in this process. And humans make them, humans share them, humans can fork them. That's where we are. That's what we mean by agents. We're creating these really limited bundles. What we're going to see over the next year is automation of that, where the AI actually selects the tools and the AI renders apps on demand. We already see this with artifacts and things like that. And then we're going to do the sharing at the end. We're going to save these. We're going to wipe out the vibe coding industry, right? Because then we'll vibe code from that point, and we'll put them out for discovery. We really have to solve 3 problems, and I think we will solve these problems over the next year to do this. Discovery, so where are they? I agree with the people who said that's not a hard problem. Computers can find almost anything. The problem is you discovered 10,000 tools. Now you have to select the right ones at the right time. There's a lot of ways to do this. There's the human way. There's training models to do it. I actually think that's pretty important. We're working on that. And then finally, self-generating apps. We just wiped out the whole app industry because our AI can discover and use apps. We're going to rebuild them for the AI. It's actually going to spit out agents and refine those. So that's why I'm here, to get these 3 things to happen. Thanks.
Button again? Which button again?
This button right here.
Okay, got it. Okay. Hi, everyone. My name is Ragu Bala. I'm the CEO of Synergetics. We are a platform that powers the agent economy. And first of all, I'll start off with some basics. So a lot of the early platforms were built with single agents in mind. So we built our platform with a multi-agent mindset. And these multi-agents can operate in 2 ways. One is within the enterprise, and one is beyond the enterprise. There is an agent from one company trying to talk to an agent from another company. So this first variation of agents within an enterprise, fairly straightforward. You can use many protocols for communication and so on. And then beyond the enterprise, you have certain challenges because your ID is no longer valid. So within enterprise, you can use your IAM, your auth zeros, and your octa, and things like that. But then outside the enterprise, you need a DID. So we first started off with doing DIDs, as well as putting these DIDs in an agent registry. And our agents are they are tokenized at the core. So they're actually NFTs. These agents are actually NFTs. They have IDs, registry, names, wallets, and everything built in. Okay. Now, there are a couple of things that are important. First is the decentralized ID. And then you also need a verifiable credential so that someone signs off to say that this ID is valid and it's gone through a KYA process, so you don't have any bad actors in the registry. Now with NANDA, I think we had the privilege of being involved very early and started working on various things within NANDA. And the first is we actually have a sandbox version of the NANDA quilt that we have built. There's a QR code that's on a poster that's out there somewhere that you can go and scan, and you can use the sandbox, where it actually ties the various registries into a single registry, which is the quilt vision. So we have at least a first working version of it. And then also support for various protocols. We have our agent talk protocol, which is patented. But one of the things that we really focused on was A2A, for example, does not have any sort of schema or structure for communication. But if you know EDI, which is used in supply chain, if you use HL7 in healthcare, and so on. These are all structured protocols. So you need some structure when agents talk to agents. Human talking to agents will be natural language. Agents talking to agents will need some structure. OK, moving forward. So for the two RFP items that we are proposing, the first is any agents that are out there, we can ingest those agents within our platform and give them the same capabilities that our agents have. And this enables agents to be interoperable with one another. So you can have an agent from Crew AI talking to an agent built with LangChain, for example. So they get a set of capabilities, ID, name. We have the .twin web3 TLD. We have several thousand registrants already. The wallet, we have the first agentic wallet, where your agent can actually go and spend money. It can be both Web3 type money, crypto, stablecoins, and so on. We're also building Web2 rails for those who don't want Web3 money. So, and also you have Agent Connect for those who know Wallet Connect in Web3 world. Agent Connect does the same thing, but for agents as opposed to humans. And then the Agent Talk protocol and so on. And then for this communication I mentioned between agents, you need a structure. Because just using NLP between two machines, there can be a lot of ambiguity. So to prevent that ambiguity, you need structure. And we are rolling out a protocol definition toolkit that enables you to provide. I see the time, it always throws me off. But anyway, this gives you a structure for the payloads and so on. And that makes the communication between agents a bit more, you know what you're going to get at the end of the day. There's no ambiguity. So those are two sort of tools that we are proposing for the RFP. Thank you.
Thank you, Ragu. I'm excited to have you come to the workshops and contribute more there and make sure we document your ideas. For the last group, they are not here. They have sent in a video that I'm going to play. Oh. What do I need to do in order to play the video? Oh. Stop. I have to stop sharing? Okay. Sorry. I didn't realize. You know, while you're doing that, I'm actually going to stop my echo first. Maybe I have to mute myself. Is that while Chris is helping me set up the last video for a team, Leon with Ensemble codes, we had a steering committee, and we're still building it out, but we had a steering committee review many of the proposals, most of them. And one of the steering committee members is here and flew all the way here last minute. So I would like to invite Amer up to stage, and I'm asking him to give just a 3-minute commentary on, as the person who reviewed these proposals, now that you've seen the morning where when you scanned the landscape, right, where our speakers with Michael doing the moderating, you've heard that input from the landscape. And then now you've heard these proposals. And before we go into the workshops, where we're now really going to be like, these are the constraints we need, or these are the design principles we need to have, what are your immediate thoughts? Could you give a 3-minute kind of discussion while we have, your feedback while we get this set up? Thank you so much.
Yeah, thank you, Trisha. Thank you, Ramesh. Very quickly, hate to be the last person between you and lunch, so try to keep it quick. When I reviewed all of these proposals, the main things, a few things that I looked for was, first and foremost, community ethos, because the NANDA project has a very strong community ethos aligned with this, and I think the alignment with the community ethos is extremely critical. Number 2, then I looked for was the technical level feasibility. So a lot of pie-in-the-sky ideas out there. It's great to have that part of the research, but the pace at which the innovation is moving, technical feasibility is very important. That means, do you have a proof that you have done it? And then is this something in the proposal that was there? Number 3 that I looked for was radical imagination. Radical imagination in this space is extremely important because of all the aspects that we talked about. And as we go into the next workshops, What I would challenge, especially the solution providers, and as well as all of us in the room, is to take that radical imagination to radical reimagination. And that as a design principle and ethos are very important. And the reason for that is that as we look through these solutions and then chose them, they all have, you were looking through this, you may see there's some threads that kind of connect them, almost like weave them together, almost like a quilt. There's a reason for that. And then the reason for that is that there are bits and pieces of the building blocks in each of these that are there that are needed to bring this interoperable quilt to life, right? So as we think through the workshop and actually go into the workshop, let's take a first principles perspective to the problem we're trying to solve for interoperability, and then come to the table with a radical reimagination as the design ethos, instead of leading with and trying to push or shove the problem or the solutions that we have seen through. Let's not shove the solutions into the problem. Let's start with understanding the first principles of the problem. What are the critical aspects of a fully interoperable and open internet system or agentic internet that we're looking at? So that's what I would challenge as a design principle as we go forward. Thank you. Can I? Sorry, one last thing, and thank you for bringing up HL7 Da Vinci. I was at Cambia Health Solutions. We are one of the members of the Da Vinci. Those who don't know, it was an interoperable healthcare data ecosystem. Many people think it's a success. I'm part of the group that thinks it was a failure. It turned into another walled garden that was created by the system. Right, so there are, similar to that system, there are now, within the agentic ecosystem, there are systems creating their own walled gardens, which is why we need to kind of take this radical reimagination into it. Thank you.
Thank you so much, Amer. I have to say that your feedback on radical imagination is so important, because this is why we have a presentation like from Sharath Chandra on thinking about what does a multi-agent or open agent registry look like for space. You know, if we didn't think about building out infrastructure before a use case, we wouldn't even have space travel. We wouldn't have any frontier technology that's being invested in. So this is exactly why Project NANDA is here, is to think about, you know, giving us, like, we don't have many people, everyone is saying agents, but not many people are doing what Ramesh is doing, which is actually painting a clear vision for what the future looks like after the internet and after agentic web, and what does that actually mean in an actual, like, step-by-step practical way. So we have a roadmap. And so we invite you to bring this radical imagination for the speakers and the solution presenters to the workshop that we're going to do as invite only, but bring it to the rest of the event for the rest of the day and tomorrow. So thank you, Amer, for using, you know, really bringing us home with that concept of the phrase radical imagination.